All right, guys, so welcome back. So you can see I have my coil slide. See how it works? This guy's got a little clamp here. And I did a short on this, the happy design accident. So I thought I was going to have to rig something up, but it turns out it just slides right on. And then goes like that. So I don't have to, because if I had to permanently attach it, it would be really wide. It would make the system really wide. But now I can put any coil in there. This guy goes on here like this and screws up like that and slides in and out. Cool, huh? Yeah, I like these little accidents, these happy design accidents that happen once in a while. Most of the time it's something negative, but this time it was something positive. So now I can fire this guy up and check out the different speeds by actively pushing the coil in closer or pulling it out. So let me try that. Stay tuned. So I finished these guys. I needed to put a little back brace up there because the coil would tilt. But I've just had a different idea. I'm going to put this guy away and get out my large Newman motor and use this one and the other rotors that I've just created over the past week or so inside that giant Newman motor. I bet you it'll work out really cool. So stay tuned for that. So I don't know if you guys remember this beast, the giant Newman motor. Here's my hand. And here is the core that's in there. It's got huge ring magnets in that are pretty well secured down, but I have this cover which really isn't all that good. I've got a better cover for this, but just to show you how this guy goes, that's at 8 volts. Yeah, that thing is flying. The camera doesn't do it justice. But I'm going to put these guys in there, all of these different rotors that I made over the past couple of days. This guy, the big one, the round one, and that one there. Let me turn it off. And I've got a better cover for it. I have this big acrylic plate that I'm going to use just to be safe. I'm actually going to use this big acrylic plate for the front of the other stand I have. But I wanted to get this guy out. I really like this. The coils came out really nice. Not a lot of winds on there. I think there's like five layers. I'm not really sure. I broke the top of this piece off. I gotta fix it. But yeah, I want to get this guy in there. Hopefully he'll fit. Yeah, he'll fit in there. Oops, sorry, my wounded hand was getting in the way. All right, stay tuned. So I got the first one in there. It's not very impressive. It puts out really good output. It's only at 8 volts. Let's crank it up. There's 12. There's 12 volts. That's pretty good. Whoops, I forgot to put the collets on. Let me turn that down. I forgot to put the collets on to stop it from sliding around. These guys right here. Yeah, so 12 volts, it really moves, but I got to put the collets on. All right. So it does It is pretty nice. Let me show you what this one is. This one is the one with it's just a 4-pole one with the little barrel magnets in it. Yeah, let me put the collets on and get it going again. Stay tuned. There it goes. Let me put this up here just in case. This thing is flying. Solid output. Yeah, that is flying. It's actually vibrating a lot. Well, not vibrating a lot, but because it's going so fast, it's causing it to kind of walk across the marble top here. Yeah, she's flying. Yee. I don't know how much I trust that PLA. I gotta cut the acrylic, the thicker acrylic. It's like 1/2 inch acrylic for the top of that. I mean, this would stop it a little bit, but not by much. Those little cylinders would come out like a freaking bullet. All right, one down. I can't wait to get this guy in there. I made some new housings for it, though. I mean, some new sleeves. One's going to go on that side, and one will go on the other side. Orange and black. See how that holds it up. All right, stay tuned. All right, so here's the heavy-duty rotor. Man, this thing is heavy. And you can see it's got a lot of magnetic power. Anyway, I've got the two new shields on there, so to speak, or sleeves. So let me get this on this rod and get it installed there and see what we can do. Stay tuned. All right, so I got it in there. I'm only running it at 8 volts. Really good output. Let's crank it up a little bit. Yeah, it's doing really good. Solid output. I'm seeing solid lights. The camera is showing a reflection or a strobing effect, but it's solid. Yeah, that thing is powerful. I don't think there's any way those rectangle magnets can come out. It's funny because it's not going as crazy as I thought it would. But it's working really well. I want to try a few other rotors. I've got this one, I've got this one, and I also have this big guy I want to try. I think I want to try this one next. You can see my shop is a disaster. It's got a little bit of a wobble to it. I don't know why. Let me check it out. Stay tuned. So I didn't think this big monster was going to fit in here, but it is. And I should get some really good output and RPMs with this because it is so big that I'm going to be gathering more of the magnetic flux from the coils. But let me get this guy put back together. Let me get the collets on there and I'll bring you back. Stay tuned. Dag nabbit. So I was racking my brain. This guy does not work in here, and I realized why. There's too many poles. If I were to take out, that has what? 1, 2, 3, 4, that has 6. If I were to take out like 4 of those magnets, this thing would work great. I was going nuts. I changed out to the Waco because I thought I had a bad connection. But yeah, I just confirmed it has too many poles. Unlike the little one, and it's too big because of that. It's too big and has too many poles. The little rotor that I had in there has 4 poles, and so does this guy. This guy's got too many poles. I was afraid of that. Let me see what I can do. Maybe I can... I think I can run it with just one of the coils. I can't run it with both of them. Let me see if I can run it with one of them. Stay tuned. Yeah, so too many poles. This one has too many poles, and that 6-pole one's got too many poles. 4 poles, maybe 5 will work. Let me shut this off. I don't have the collets on there. Yeah, I was going crazy. Too many freaking poles. God damn it. I'm still trying to figure out how I can work that big one in there. Let me see if I can take it apart. It's not glued, so it's only screwed. And I can do the same thing with that one. I can turn it into a 3-pole rotor or a 4-pole rotor. Let me do some experiments. Stay tuned. All my testing shows that although this one worked, it's at the limit. So 4 will work, but it also depends on how they're oriented. This one obviously is not going to work because the poles are oriented out that way. It would probably still work if it was just 2 poles. That big bastard down there is definitely not going to work in it. The best one is this one right here. Of course, this is only 1/2. Ah, come on. And that's not the dual. I just have it hooked up to this one. I don't have the collets on. Let me slow it down a little bit here. Yikes. That hurt. Yeah, so the Newman motor setup, 2 poles. 4 poles will work, but it depends on how they're oriented. Damn, I was really hoping to get this guy and that big one in there. Well, at least this one worked. Yeah, at least that one worked. I can get that one back in there and see what kind of speeds I can get going on there. This is the best one right here. Although it's too loose on the shaft. I have to 3D print some kind of support piece for it or brake for it so it'll stay on the shaft. It likes to walk. The shaft I can stop with the collets, but wherever the other ones went. All right, let me see what I can do. Stay tuned. So it's not a total failure. I upgraded my connectors to the Waco or Wago, which I wanted to do anyway. This one's got a little bit of a wobble, so let me turn it down a little bit. There's 7 volts. Of course, there's only one side of the Newman motor. Yeah, I got to figure out why that thing is out of balance. It was okay with the other sleeve. Maybe I've got some elephant's foot on one of the ends there. Oh, I better stop. I don't have an output on this. I'll burn up that diode in a minute. All right, let me see what else I can do here. All right, stay tuned. I took the sleeves off of the big boy, and it's running a lot better, a lot truer. Yeah, that's 7 volts. And it's cruising big time for 7 volts. Let's turn it up just a little bit. Getting solid output. There's 8 volts. Let me get my big shield. Yeah. Put the big shield up. Forget this little tiny thing. I don't think it'll do anything. I really should build an inner shield for here so I don't destroy my my coil. All right, let's turn it up a little bit more. Oh yeah. Solid output. Blinking for you guys, but solid for me. Nice. Very, very nice. All right, I have to figure out, let me turn it off. I gotta cut this, make like like a cap just like this guy here. But definitely out of this. This is much thicker. But I don't want to destroy my coil. But hey, you know what? If it happens, it happens. What am I going to do? What was I going to do? Yeah, so those are only good in my vertical stand over there. That guy right there. Yeah, I got to take it easy though. My hand is killing me. Messing around too much. Freaking doctor's going to have a fit. All right, guys. Sorry it didn't come out the way I wanted it to. I wanted to get that big guy in there. This guy's really nice, though. I got to fix him so he can go back in there. The hole's too big, so I got to put a couple of brakes on either side. That's what RD3DP calls me. Calls them brakes. That's what I'm going to call them. I didn't know what the hell to call them. I'd like to try this guy with the Hall sensor circuit, see how it works. But maybe we'll do that next week. Thanks for watching. Ciao.